Hello, hello everybody. Yeah, can you listen from me now? How you all today? Welcome to 2022 and welcome to Zion Educational Channel. If you today is the first joining to our channel, please do share it out. Please do share it out. Share to your friend whoever to like the power electronics. Today our topic is talking about the AC to DC converter. First of all, if you just joining to our channel, okay, if you just joining to our channel, please do click a like button, share it out to your friends. Happy New Year to everyone. Happy New Year to everyone. Do you able to listen my voice? If you're able to listen my voice, do comment it. Do comment it. Do give a do comment 1 if you able to listen my sound. 0 is no. Okay, I would like to see everybody able to hear my sound, Do you able to hear my sound? Hear my voice? Hello everybody. Do you able to listen my sound? Do you able to listen my sound? I think it's quite low, quite soft. My sound. Is it my sound is quite soft? Hello, hello. You all able to listen my sound? Hello, hello. Wow. I think it's very soft. Yeah, maybe you need to increase the volume, then you're only able to listen my sound. How about the screen resolution? I think it's very poor. If you just joining into our channel, first please set the quality setting to the 1080 60 frames. Okay, so you're able to see much more clearer picture screen resolutions from my channel. Okay. If you have joined, please comment down below. If you have joined, please comment down comment it below. If you have joined, please comment it below. So Suddenly so loud. Sorry. Suddenly the desktop audio is so loud. Do you able to listen my sound, my voice? I think right now is much more better. Yeah, just want to open some background music so that everyone's it's not so boring during when we doing this live. Hello everyone. Do comment it down below if you have joined to our channel. Maybe wait for another 5 minutes. We will be start. How you all? How you all? Yeah, please written down your name, your country, and attach if you have attached to a company, to written down what's your company, and if you not, then which university that you have been attached to. Okay, please comment it down below. Okay, please comment it down below. What is your name? What is your background? What is your uh, sorry? What is your name? Then you are from which country? If you have attached with a company, please written down your company. If not, do written down your university or you are from the preschool. What kind of your school name? Please written down in our comment below. Thank you. Hello. I think right now the sound is much more better. Okay, so I will try to start in a very short while, in another 2 minutes time. If you have entered, please comment it below. If you have entered, please comment it below, so that I have know whether you have joined our channel or not. Okay, so we shall start our today topic. Okay, all right. Let me go down a bit. Okay, welcome. Happy New Year to everybody. Happy New Year to everybody. Welcome to 2022, and welcome to Zion Educational. If today you are the first time joining to our channel, okay, our channel basically is talking about the power electronics, but we are using Matlab to do all the simulations. Okay, we are an educational channel who would like to let everybody know how everybody familiarize with the Matlab. Matlab basically can do a lot, tons of the things that can help you to do much a lot in here. Okay, we hope you all can enjoy this channel. Okay, so basically our target audience is the MATLAB power electronics for electrical engineer. Is a I will say it's a short course. Okay, so do follow our this short course. It could be if you take a basically our channel every week every week Saturday and Sunday. Okay, in Malaysia time is around 9 to 10. Okay, around 9 to 10. Okay, we will spend around 1 hours to share out all our knowledge in here for the power electronics. Thank you very much. Okay, so we shall start today our live tutorial. Okay, today our live tutorial is as per our thumbnails. Today we will more focus on the AC to DC converter. Okay, which is the rectifier. Okay, if you know the rectifiers, then do give a comment. If you do comment it as the one. If you don't know, please comment it as the zero. I would like to know you all what you all level. Please do comment it below. Okay, let me see. Okay, so oh wow, so many people. Oh yeah, I think you all are the engineer. Okay, so you all is quite familiar to this. Okay, so I saw a lot of one. Okay, thank you very much. Okay, for those who do not know what is the rectifier, maybe you can try to Google it. Maybe can try to Google it and understand more for the full wave rectifier. If you not then you are a bit hard to follow on today course, but don't be worried. You can listen from here, then you can after this live tutorial you can go Google it, what is the full wave rectifier. Okay, so today we were talking about the full wave rectifier. Okay, I will make a summary for this tutorial. Okay, after you watch this live video, you should able to learn what is a AC to DC converter. Okay, what is AC to DC converter? Okay, then uh, AC to DC converter basically is a AC source. Okay, so maybe I will try to explain it more. What is the AC source to you? Okay, so let me change my screen. me change my screen. Okay, so let me bring you to find a AC source for you, so that you will more familiar what is the AC source. Okay, so you can go to the Simscape here. Okay, so you're not familiar what is the AC source, maybe you can try to go to the electrical specified power system. Okay, then go to the fundamental plot electrical source. Okay, we are looking for the electrical source. Okay, so I will try to bring it out one AC source for you first, so that you will know what is the AC source. Eh? Then what is the DC source? I will try to demo for you later it on. So once you get one AC source, maybe I haven't bring it down. Uh, when you have bring it down one AC voltage source, then maybe you can look for another things. It's called scope meter. Okay, so or it's a, I will say it's a oscilloscope. So for those who study electronics, then you always will use the this oscilloscope. Oh, so basically when you all coming into this Fullwave Simulink, you all can go to the Simulink library browser to search whatever do you need. Okay, so if you're talking about the power electronics components, I will advise you to go to this. Okay, Simscape. Okay, the Simscape components in here to look for electrical. Then you will go for the specific power system to look for those components that you really need in here. Okay, so I will come again one more time. I think it's a bit slow. I able to bring out the scope, but I haven't able to bring out the AC source. Okay, so yes, a lot of people will comment it. Oh, using Simulink very lag. Okay, so bear with me because we are doing the live channel, so it might be have a little bit uh, lag, but maybe it's my computer issue. Okay, I will try to solve these computer issues as soon as possible. Once you all, if you all like really like if you really like to my channel and would like to know a lot of sharing for this, okay, so I do like it, then do share it to more your colleague, friends, families who like the power electronics as well. Okay, do share it more so that oh I can earn some little bit money in here so that I can purchase a new computer. Okay, so yeah, I, you can try to drag it out, or if you cannot drag it out, you right click. Okay, then you can add block to the model. Okay, so it also will display back to here. Okay, it also will display back to here. Mm. Eh, do you all still able to see? Oh, sorry, it's very slow. Okay, I just would like to explain what is the AC source. Okay, so this one AC source. Okay, maybe I do a simple connections in here. I find an interface element. I find RLC branch, a branch. Okay, so I just would like to share to you all how it goes. Okay, I will press the Control R to rotate the element. I will press the Control R to rotate the element. Okay, so because I just would like to show to you what is the AC source, but today our focus is not this. Okay, just okay, let me set a voltage source to uh, 230 Malaysia's one. To okay, so we are in the 50 hertz. Okay, why I put the square root 2 in here because it's a big voltage. It's a big voltage. Okay, so I also will start to the measure the voltage in here. I will measure the voltage in here, and I will press the okay, so I will find a multimeter. If you want to find some element, you can press the element in here. Like if you know, I want to find a go to, then yep, then it will be easy. You can drag like this, find go to. Okay, so for a go to, it must have a from lah. Huh. Okay, so if from because if you want to go to this from A point, go to this A point. Okay, this A point is from this A point. Okay, so this multimeter basically just now I've been showing up in here. I've been showing up in here, which is the uh, we have do the measurement. So I will try to display the measurements back to the multimeter first. Then from the multimeter basically is like a probe. It's like a probe for the oscilloscope. If you have been used the oscilloscope before, for sure you will be know. Oscilloscope basically have a probe. You need to probe the the voltage. Okay. Then after you probe the voltage, then you can display it out in the oscilloscope. Okay, same go to here. We will use the multimeter to do the measurement, but because after we do the measurement, if you have the multimeter, then you also will have the probe. You need to probe on the voltage, whichever locations that you would like to measure. Same go to here. Okay, today I would like to just to showing up to you what is the AC source. That's why I am trying to probe on the AC source there to looking for the oh can't do on this way also. Okay, once again he can't do. I think has some still have some technical issue in here. Bear with me. Okay, maybe we don't want to use the multimeter because every time when I do the live, I couldn't use the multimeter. Okay, you have been joining me continuously in here. Then you know this issue very well lah. Okay, but basically I will try. I still figure out a way to solve this out. If whoever who know this, how to solve it, you can comment it down below to let us know how to solve it. Okay, so since we having problems, okay, we also can go to measurement in here lah. Okay, because we would like to capture it down for the wattage. So it might be like I bring a positive in here, then a negative. Usually I will not name AC source is a positive and negative. I will name AC source is a live and one is the neutral. Okay, so for here is live, neutral is going back. Okay, to avoid the confusions in here, a lot of people will say, oh, AC source positive, AC source negative, then it will be make a lot of confusion in here. Okay, I will be much more prefer naming out the AC source is the live and the neutral. DC source will be the positive and the negative too. So to differentiate between the AC and the DC, so everybody will be much more clearer in here when you're talking about the live, neutral, and the positive and negative. Okay, so we have been model it. Let me bring you to see what is the AC source. If you do know what is the AC source, so it's important to know when we want to learn the power electronics. Okay, when we want to learn the power electronics, the main idea is we would like to know what is the AC source, what is the DC source, because a lot of time when we using the power electronics, we would like to convert it from the AC to the DC or from the DC to the AC. Okay, you also can do something like from the AC to the AC or from the DC to the DC. Okay, this will be talking. We will try to talk after the channel. Okay, after this channel. Okay, so sorry, we are lefting out the power grid component. So one very good things you all have to be always remember putting it down the power grid component in here. Today I will show you in the continuous. So we also will talk about the discrete after this. Okay, discrete is much more advanced. So but because of today we are still today is our first day in the 2022. Okay, 2022 is how to say I will say it's a great year ahead. Okay, so so do bear with us. Okay, we will continue we will use the continuous mode in here. If you not familiar with the continuous or the discrete in here, okay, I will specifically do a video to talking about the comparison between the continuous and discrete as well. Do stay tuned to our channel, and then you all will know much more better in here. Okay, once you have the continuous, then basically we have the three. One is the continuous, discrete, and the phasor. Okay, the simulation type lah. Okay, so I will build a video. I will create a video purposely to talking about these three things. Okay, continuous. What is the continuous? What is the discrete? What is the phasor? So you will be know much more better in here after this. Okay, then I will be also will talk about the tools. Once you follow to our tutorial lah. Okay, when we want to use then I will talking about it. Then the preference as well. Okay, so just would like to show in here. Okay, you can press the start, then basically I just want to show the AC source. I didn't predict I will say so much for this. Okay, so you will be take a little bit of time to generating some component. Okay, if you have, if you want to use the Matlab, I do recommend that you try to increase your RAM. Okay, you try to purchase a computer that with at least have 12 to 16 gig RAM. Then is, oh, I will say fantastic lah. Then if you have the SSD for your hard drive, yeah, then I think 50 gig to 1 terabyte is very suitable. Or if you have lesser, then no worries. Okay, no worries. Okay, you have lesser the capacity in here, no worries. We will add it lah. Okay, so we can open again in here. Oh, quite long. So sorry. Point two. Okay, this to setting up the timer. Yeah, I just want to do a quick running in here to show to you. It's a bit poor. I think some setting is wrong. When you do the continuous, then you also have to go for here. What I advise here, if you didn't do, because if when you want to see a good, how to say, a good simulation, then you need to set the setting is correctly lah. So bear with me. Okay, we will do it one by one. In here I will try to use the fixed step. Okay, try to use the ODE. Okay, 23. Okay, so that you will see very smooth sinusoidal wave. Because just now the AC source basically is try to generate the sinusoidal wave. Okay, so you is we will try to run with a fixed step. Let us run again. Some setting is wrong. No. I think it's still in the variable step. Okay, if you want to see fixed step, then so you need to go for the variable step. Let's check again. Sorry, excuse me. It's still not a smooth sinusoidal wave. Oh, yeah. One more things. Yeah, do bear with me. The max step size. I think if you want to simulate it with better simulations in here, you can try to use the 1E6. Try to limit the step size, so that you're able to see a much more smoother how to say much more better this sinusoidal wave compared like just now we put it in the auto because he how to say he would like to generate much more faster simulations so he taking out a very how to say small small step sorry very big step okay as you all know okay like, just to share more information just to share more information so that you all will be much more clearer in here okay our frequency is 50 hertz okay so come to here I show it to you okay so we can try to calculate a bit let's say my frequency f equal to 1 divided by 50 okay basically it's a 20 millisecond okay 20 millisecond then within the 20 millisecond we need to step it out how many steps so I will advise is much more smaller than the 20 millisecond definitely okay so that's why we are putting in the that's why we are putting in the 1e6 that's why the reason in here is we are putting in the 1e6 is because we would like to step it put the every single step size display it out every single step size in here so that you can see a very smooth sinusoidal wave you can see a very smooth sinusoidal wave in in here okay so if you just I will try to demo you I change the step size to something faster than the 1e6 okay something faster than the 1e6 let me share to you okay I will close this one I will be close okay so we go to the setting in here yeah we go to the setting in here you can see much more clearer okay just now we are in the 20 millisecond so let's say I put 1e3 millisecond okay so you can see the difference okay it's not it's not smooth okay like today I put much more bigger much more faster than it will become very weird things 1e2 because the step he didn't collect the point at all it could you cannot take everything much more faster than the 20 millisecond if not you couldn't see the sinusoidal wave so that's why to get a good result I will advise you all you can do the setting in here change the setting to 1e6 I think is a good one but it depend on what kind of simulations that you want to do okay 1e6 basically is around megahertz okay so you all can be calculated after this okay or you all can take a tutorial to calculate because we know our frequency this command window is hang stay with me. Oh yeah, I come out. Yeah, see, 0.2. Okay, what is the 1e6? 1e negative 6. Okay. Oh, shoot. How to display this? Uh, Shane, Shane, it's much more smaller step size. Frequency, we know the time equal to 1 divided by f. 1, what is the 1 divided by f equal to 1 divided by f equal to 1 divided by t. T is the 1e6. 1e6. Okay. So it's 1 megahertz. Okay. It's 1 megahertz. So try to imagine for after this we will try to control, because after this tutorial we will, how to say, we will try to do some control for the system lah. Okay, I would like to show you in much detail lah. Okay, so because some of the system some of the controller that we would like to talking about is 40 megahertz. Okay, 40 megahertz. Okay, so it means 40 mega is e6, right? Okay, this is the 40 megahertz. 40 megahertz. Okay, this is the 40 megahertz. If we calculate the 40 megahertz, what is the time? Is 1 divided by 40 megahertz. Okay, you all can set until around here. This after this, when we talking about the controller, which is the 40 megahertz controller, want to control the IGBT. So you can see how fast the firing will be putting it in here. Okay, so right now you all is familiar is the AC source. I think, yep, right now you all is familiar with the AC source. AC source, basically they have a positive part and the negative part. Okay, if you call AC, alternating current. Alternating current means they have a positive component and the negative component. If you call AC, okay. Then I will try to show to you what is the DC. Okay, so we go back to this source. This is the DC voltage source. I bring it out. I remove this AC source. Okay, remove this AC source. Then I will putting it down in here. This DC source. Same. Maybe I put just now 230 volt. Okay, so I will run it for the DC source. Okay, 230. Yes, positive only. Okay, this is a positive value only. This is the DC source. Our ultimate goal is change just now the sinusoidal waveform to something in here. Okay, we will change to something to be a straight line, which the DC. Okay, so I think I have shared too much, talking too much for the AC and the DC. Okay, so hope you all understand. Hope you all can be follow. Right now I will go to build a model, AC to DC model. Okay, whoever like it to join for us again. Do stay with me. Okay, if you all want to take some break, okay, do take some break. Okay, do do take a quick break in here. Okay, do a quick break in here. So yeah, we will continue in a very short while. We will continue in a very short while how to do the correct things in here. So I will run it for DC source. Okay, ready? It should have positive value. Okay, this is a positive value. This is the DC source. Our ultimate goal is to change just now the sinusoidal waveform to something here. Okay, we will change to something to be should have reach the DC. Okay, so fast. Okay, too much for the AC. Maybe DC. Okay, so you all understand. You more familiar. I will right now. I'm going to build a model, AC to DC model. Okay, whoever like it to join for us. Okay, so okay, so we will continue in here. Okay, very fast. We like to continue. Okay, very fast. We would like to continue in here. Okay, so first, because today we are talking about the three-phase system, so I will bring the three-phase. You can use this method, add block to the model full-width rectifiers. Okay, so the full-width rectifier basically is this here. So I adding this block to here. So you can use this method to calling all the components that you would like to use in here. Okay, so that later on you will be much more easy. Later on you will be much more easy to use it. Okay. Okay, so it will be a place in here. Then we want a three-phase source. Definitely, we would like to get a element. We would like to get a element. I always will use either the series ILC branch and the series ILC load. But today I will show it out. What is these two? What is the differences between these two? Series ILC branch and the series ILC load. Okay, so when you double click on here, okay, you can see the setting is Henry Farad. Okay, then if you putting it in here, it will be for the load. You need to key in the information is what is the voltage frequency, what is the active power, what is the reactive power, what is the capacitive reactive power in here. Okay, so for those engineer, for the engineer who, because we are engineers, so usually when we use the item when we use the item like today we are bringing in a motor, induction motor. uh, when we use a induction motor, the induction motor basically he will tell you how many kilowatt for this induction motor. Then it will show you what is the power factor. But eventually you do know what you do know what is the resistance inside the electrical motor, or what is the inductance or what is the capacitance in here lah? What is the capacitance in here? Okay, so what I will be suggesting you if you are the engineer, yes, definitely you will go for select this series ILC load. If you are the scientist or if you are the student, you would like to build a new item out yes, definitely you will be using the series IRC branch. So because of today, our course is talking about the for the for this Matlab Simulink for the engineer. I will advise you all you use the series IRC load using the load. Okay, so it will be much more better understanding in here lah. You will have a much more better understanding in here later on. Okay, then what else we need? We will go for the power electronics. We'll go for the power electronics. Today, uh, I will use this. I will use the three-phase bridge first, to discuss with you all. So, but basically we can use a lot different type because this is the three-phase, three-level bridge. Eh, sorry. Um, I think two level one is. Sorry. I think universal is much more easier for you to follow first. Okay, I will talking one by one. What is the difference in here lah? For those bridge, how to use the power electronic bridge. Okay, so you, you already have this and this. Then I want to generate the pulse in here. Let's say you today you don't know how to generate the pulse. You can go double click in. Okay, you go to the help. Basically, the Matlab Simulink, the help is very powerful. He already documented out all the useful informations for you to learn how to use the components in here lah. So he have explained in very detail, but you do need to spend some time now to go from A to Z. Okay, you need to take some time to go for A to Z. Okay, so over here you can know what kind of topology that you'll be using it, or then how to what is the stubble capacitance things. Okay, so uh you need to go through it in a much more detail. Then G is the gate, how we able to firing the gate. Yeah, power electronics always talking about we are trying to firing some gate to get something else out. Okay, so G basically is the gate. Okay, so you can see over here the G over here is a gate. So then we need to understand how we going to firing the gate. So we need to fire some things that can be firing the gate in here lah. We don't need to build because we know the basically you can build, you can build, but I will advise you no need to build because Simulink have do a lot of very convenient stuff for us. You can see pulse and signal generator. Okay, so we would like to generate a PWM generator, so I will always to be use this first. Okay, then you this component, you can press the control, then again, yep, then he will be writing it off. Okay, seems go to here, seems go to this one. I do it one more time. I rotate this. Where is the, okay, so this one and this one, okay, and this one, you press the control, you press the control, yep. You can routing it like this. Okay, it's much more simple and easier. Okay, then yep, we are done. We have done. This is our AC part. This is our DC part. Okay, so we already done. Okay, so I will start something easy. So it's use the pure resistor load. Okay, pure resistor load. So because when they want to use the three phase, I will use our country voltage. You can use your country voltage also. Yeah, from US, maybe you can use the 380. Okay, you can use your country voltage. Okay, depending on what is your country voltage. Okay, you do comment it at the below. Do comment it at the below. What is your utility? What's which country that you are from? Then what is your utility company voltage from what utility company? Okay, I believe some of the country that have a lot of utility company, like what I know in Japan, they have two very big utility company. Okay, then in Malaysia, we just have one, and some of is the we just have one utility company lah. Okay, so in some other country they have two or three like US. So okay, so do how to say, do comment it down if you do comment it down so that we can build a small database in here. Okay, and fast and easy. Because if me myself, I also not try familiar to your country. So maybe you are familiar to your country, you can do comment it down in here so that we can share these informations for the rest of the people that would like to know in here. Okay, so I have been setting down this resistor, then I will go to here. Okay, I will be use the wire with the ground, 415, sorry, 400 volt. Okay, face to face is 400 volt, 50 hertz. This is the short circuit level. I can left it down in here as the same. Okay, then I will be bridge is the 3 snubber. Everything I didn't change. I will try to use the Thyristor. Okay, after this course, maybe you can try to use the, how to say, the IGBT. Okay, if you want to use the IGBT, I would like you to try with the IGBT, because in this is a bit latest technology. Okay, so I will talking in another course. Sorry, but not in another course. I will talking it after this live tutorial lah. Okay, how to use the IGBT is a bit different. IGBT and the Thyristor is a bit different, but I today I will try to show you the Thyristor. Then you need to figure it out how to use the IGBT. Then please do your homework. Do your homework. Then we will discuss maybe 1 week later. Once I see you all have been uploaded your file, then I will be discuss on it how to use the IGBT. Okay, because the IGBT is very powerful. Or if you don't want to use the IGBT, you can use the MOSFET lah. Okay, if you don't want to use the IGBT, you can use the MOSFET. Okay, seems MOSFET also very powerful in the future. Okay, so I will start with something simple. I will start with the Thyristor, then we will discuss after this. The, then I will purposely do a video to show the differences between the IGBT, Thyristor, and the MOSFET. How we going to configure for it. Okay, basically we have a lot of topic to talk about it. Do bear with me. Do stay tuned to our channel. If you like it, please click like, subscribe, and comment it down below. We hope you do more sharing in here. Thank you very much. Okay, I think for those who stay until now, okay, or for who stay until now, do bear with me. Okay, maybe I talk too much. We are using the 3-phase 6 pounds. Okay, so the mode operations. Okay, the frequency in here. Okay, how to set the frequency in here. Okay, because we are 50 hertz, we also would like to put back the 50 in here. Okay, so that later on you can see. I will today I just want to start something for you. Initial phase I will put it at the 0 first. Min max -1 to 1 first. So I will be talking this uh, after this, so to show you much more. Sorry, to show you in much detail how to use or to set or the setting, how to set all the setting in here. Today I just would like to show you how to start a model first. Okay, how to start a simple model first, so that you can get interest on it, so that you can get interest on it. Oh. So I will apply it. Then this one have been set. This have been set. This have been set. So measurement. Okay, seems go to build the multimeter can use. Okay, so we need to bring the measurement up. We need to bring the measurement up. Oh, how you all feel? Still able to follow me? Do bear with me. Do you all still able to follow to my channel? Okay. Hello. I think today have one. Hello, whoever is just joined. Okay. So yes, do bear with me. Okay. Yep. Thank you very much who have joined to my channel. Okay. So yes, if you can follow in here, do follow. Okay. So I want to do the measurement. Okay, bring out the scope. I would like to bring out the scope in here. Okay, so I will do the voltage. Then 3-phase, how we going to measure the 3-phase? Okay, so we have a 3-phase source in here. Okay, we have a 3-phase source in here. Okay, so you all can putting in over here, then connecting in here. Okay, so if you all have the how to say, have something would like to know more, would like to know more, okay, if you have some questions or you would like to know more, okay, please ask, please comment it down, please comment it down, so that I can know what is your question, then I will try to answer it over here. Okay, so back to this three-phase measurements. We see over here we have a VABC, IABC. Okay, we can change it to a label. We can change it to a label. Okay, we try to change it to the label. Then we will label it. Then we will connecting in here. You connecting in here. Okay, so you can connect everything like this, but after you already use the label ma. Okay, so later on you can call out a scope, which is the oscilloscope. Just now I am talking about. Okay, a number of port. I will set it as 2 because I will try to show 2 things. If you still remember, I will have a go to, then I will drag a from. I drag a from here. Okay, just now you all will see. I have the V capital letter A B C. Okay, the VABC. Okay, you need to name it as like this. Okay, so this VABC will be follow this VABC. Okay, if you're able to follow, this is the 3-phase input voltage. Then I need to putting in output. Then I still use the go to. Okay, go to. I will name it as the VDC. This one is the VDC. VDC. Sorry. I always will advise you to do something like this. Go to, from the go to, you put a VDC. Once you put the VDC, you press it out. Then you connect like this. Okay, then Sims go to is the setting. Okay, setting. Do remember? Today, sorry, we are start from the continuous setting first. We will start from the continuous setting. Then the solver we use the continuous. Okay, then over here, we need to wait. So do bear with me. Computer is a bit lag. Okay, so use the continuous solver. As I discussed with you all, we have a 3, but today we will discuss the continuous. Okay, so our ultimate goal is we would like to use the discrete, because later on we will build the full controller to control the this bridge rectifier, this AC to DC converter, to automatic control. Okay, whatever that you see from the very beginning, what we talking about, where does it you able to use, like I share again in here. Okay, if you able to see from my live script in here. Okay, so what is the applications for the rectifier? Okay, it can use as the battery charger for the EV. Okay, Tesla EV. Okay, you all can use it as the Tesla EV. Then if you build like this, from the Matlab, basically we can build this out. You know, if you all know, then I will try at the end of this course, I will try to build how to put all the code to the controller. I will try to share to you all lah. To stay tuned to my channel to learn for it lah. Okay. So if you say this battery charger for the EV car is too huge for me to build it up, yep, you can build a simple one battery charger for the iPhone, MacBook, okay, and the rest of the things. Okay, you can see they have a battery charger for the iPhone or a DC UPS, a DC UPS for the DC component. Then you also can use the AC to DC converter to build the power supply. Okay, the power supply to some DC component that you can use. Then the how to say the power supply for the computer. Okay. Yep. Do bear with me. Okay. Yep. Then we can go back to here about the setting. Just now we talk about the setting. Okay. Like I think just now we have discussed a bit for the setting. If you all cannot see, we try to zoom it out so that is easy for you all to see all the component. How we going to wiring it out. Maybe I start. It's a bit hang. Yeah. Happy New Year. Whoever is just join, do comment it down. Which country? What is your name? Which country that you are from? Okay. Which country that you are from? Do give me a like, comment, and share for this if you like to do the power electronics. Okay, if you like to use the power electronics, do comment it below. While we are waiting out our simulation in here, I think it's a bit hang. Can yeah, I will try my best. To invest a much more better. The dimensional. Okay. You need to use the multiplexer. Sorry. Here. Not this. I always should say, if you do know, then go to the help. They have a lot, tons of the informations that leading you to a correct how to set that dimensional things. Basically it's like this. I can use the D-Max. Yeah, you can use from here. You can use from D-Max. If you're able to see the example, yeah, you all can get some example from here. If either one, sorry, not this. Here. How you all? How you all? Yeah. If you like this, do comment it. Do comment it. You all can open this the example in here. You all can follow the example in here, so that it will be much easy for you. Basically, three. You can use this. You all can use this to make the dimensional become okay. You all can use, but if you are not sure, you can go to the example over here as well. It's a bit slow. It's a bit slow. Yeah, if you take some time, you take some time. Okay, hope you all can bear with me. Still stay in here to learn for this. Okay, to learn for this. How's your day? How's your days? How's your days? I think it's so slow. Too slow, too slow. I think it's too slow to make on live. It's too slow to make it on live. Okay, I will make a video after this to share to you all. Okay, we apologize in here. My computer is too slow for